In facilities that produce, store, or handle liquefied natural gas, adherence to both NFPA 59A, the standard for the production, storage, and handling of liquefied natural gas, and the National Electrical Code, or NEC, is required. NFPA 59A provides very specific requirements for electrical installations within areas where liquefied natural gas, or LNG, is present. These requirements address the unique hazards associated with LNG, including its flammability, cryogenic properties, and the potential for vapor leaks. The NEC serves as a general-purpose electrical code outlining the minimum requirements for the safe installation and maintenance of electrical systems. While the NEC does not explicitly address LNG facilities in detail, it mandates compliance with other applicable codes and standards, which includes NFPA 59A in this case. Consequently, facilities involved in the production, storage, or handling of LNG must comply with both the NEC and NFPA 59A. If the authority having jurisdiction or ORJ does not have a specific opinion on whether NFPA 59A should be followed in addition to the NEC, the facility owner or operator is still responsible for adhering to NFPA 59A. This ensures the safety of electrical installations in compliance with the broader requirements of the NEC. Consider firstly the scope of NFPA 59A. This standard encompasses the design, construction, location, and operation of LNG plants. These plants include import and export facilities, peak shaving facilities, and satellite facilities. It also covers the design, fabrication, installation, and testing of LNG storage tanks. Secondly, the electrical requirements within NFPA 59A are extensive. They address area classification, wiring methods, equipment selection, and grounding. The standard mandates the use of explosion-proof or intrinsically safe electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases or vapors may be present in the air in sufficient quantities to produce explosive or ignitable mixtures. Thirdly, the NEC also plays a crucial role. Articles 500 through 516 of the NEC provide general requirements for electrical equipment and wiring in hazardous locations. These articles cover different classes, divisions, and zones of hazardous locations, each with specific requirements for electrical installations. The NEC also requires the use of approved wiring methods, such as rigid metal conduit or cable with a gas-tight continuous sheath to prevent the escape of flammable gases or vapors. Fourthly, grounding and bonding are critical for safety. NFPA 59A and the NEC both emphasize the importance of proper grounding and bonding to minimize the risk of electric shock and prevent the accumulation of static electricity, which could ignite flammable vapors. Equipment grounding conductors must be sized appropriately and connected to a common grounding electrode system. Bonding jumpers must be used to ensure electrical continuity between metallic parts of equipment and structures. Fifthly, electrical equipment selection is paramount. Electrical equipment used in LNG facilities must be suitable for the specific hazardous location. Explosion-proof equipment is designed to contain an internal explosion without causing an external hazard. Intrinsically safe equipment is designed to operate at low energy levels that cannot ignite flammable vapors. The selection of electrical equipment must be based on the area classification and the properties of the flammable gas or vapor present. Sixthly, wiring methods must be carefully considered. Wiring methods used in hazardous locations must be designed to prevent the escape of flammable gases or vapors. Rigid metal conduit with threaded fittings is a common wiring method used in these areas. Cable with a gas-tight continuous sheath, such as mineral-insulated cable, is also permitted. All wiring must be installed in accordance with the NEC and NFPA 59A. Seventhly, regular inspections and maintenance are essential. Electrical equipment in LNG facilities must be regularly inspected and maintained to ensure that it is in good working order. Inspections should include visual checks for damage, loose connections, and corrosion. Maintenance should include tightening connections, replacing damaged components, and testing the operation of safety devices. Eighthly, documentation is necessary. Complete and accurate documentation of all electrical installations in LNG facilities is essential. This documentation should include area classification drawings, equipment specifications, wiring diagrams, and inspection reports. The documentation should be readily available to facility personnel and regulatory agencies. Ninthly, training is crucial. All personnel working in LNG facilities must be properly trained in the hazards associated with LNG and the safe operation of electrical equipment. Training should include instruction on area classification, equipment selection, wiring methods, grounding and bonding, and emergency procedures. Tenthly, consider the role of the AHA. While the AHA may not always have a specific opinion on NFPA 59A, they are responsible for enforcing the NEC and other applicable codes and standards. The AHA may require additional safety measures or documentation to ensure compliance with these codes and standards. The operator of the LNG facility is ultimately responsible for ensuring the safety of the electrical installations and compliance with all applicable codes and standards. Compliance with NFPA 59A and the NEC is not only a legal requirement, but also a critical safety measure. By following these standards, LNG facilities can minimize the risk of electrical hazards and protect the safety of personnel and the public. Consider the specific electrical requirements within NFPA 59A, which build upon the general guidelines found in the NEC. For example, NFPA 59A provides more detailed guidance on area classification for LNG facilities. It defines the extent of hazardous areas around LNG storage tanks, processing equipment, and transfer systems. These classifications are based on the frequency and duration of potential releases of flammable vapors. The NEC also addresses area classification, but NFPA 59A provides more specific criteria for LNG facilities. In addition, NFPA 59A includes requirements for electrical equipment that are not found in the NEC. For example, it requires the use of gas detectors to monitor for leaks of flammable vapors. These gas detectors must be connected to an alarm system that alerts personnel in the event of a leak. NFPA 59A also requires the use of emergency shutdown systems to automatically shut down equipment in the event of a fire or explosion. These systems are designed to minimize the release of LNG and prevent further damage. The NEC does not specifically address gas detectors or emergency shutdown systems for LNG facilities, but it does require the use of safety devices to protect equipment and personnel. The selection of wiring methods in LNG facilities is also addressed in NFPA 59A. The standard requires the use of wiring methods that are suitable for the specific hazardous location. Rigid metal conduit with threaded fittings is a common wiring method used in these areas. Cable with a gas-tight continuous sheet, such as mineral-insulated cable, is also permitted. All wiring must be installed in accordance with the NEC and NFPA 59A. Grounding and bonding are also critical for safety in LNG facilities. NFPA 59A and the NEC both emphasize the importance of proper grounding and bonding to minimize the risk of electric shock and prevent the accumulation of static electricity. Equipment grounding conductors must be sized appropriately and connected to a common grounding electrode system. Bonding jumpers must be used to ensure electrical continuity between metallic parts of equipment and structures. The installation of electrical equipment in LNG facilities must be carefully planned and executed. NFPA 59A requires that all electrical equipment be installed in accordance with the manufacturer's instructions and the requirements of the NEC. The equipment must be properly supported and protected from physical damage. Wiring must be neatly routed and secured to prevent strain on connections. Regular inspections and maintenance are essential to ensure the continued safety of electrical installations in LNG facilities. NFPA 59A requires that all electrical equipment be inspected and maintained in accordance with the written program. The program must include procedures for visual inspections, electrical testing, and preventive maintenance. Inspection reports must be retained for future reference. Training is also critical for personnel working in LNG facilities. NFPA 59A requires that all personnel be trained in the hazards associated with LNG and the safe operation of electrical equipment. The training must include instruction on area classification, equipment selection, wiring methods, grounding and bonding, and emergency procedures. In the event of a conflict between NFPA 59A and the NEC, the more stringent requirement typically applies. However, it is important to consult with the AHA to determine the specific requirements for a particular facility. The AHA may have additional requirements or interpretations that must be followed. Compliance with NFPA 59A and the NEC is not only a legal requirement, but also a critical safety measure. By following these standards, LNG facilities can minimize the risk of electrical hazards and protect the safety of personnel and the public. Therefore, remember that the absence of a specific opinion from the AHA does not relieve the facility owner or operator of the responsibility to comply with all applicable codes and standards, including NFPA 59A. It is always best to err on the side of caution and follow the most stringent requirements to ensure the safety of the facility and its personnel.